Okay, guys, so I'm going to do a little video here on graphing polar equations using the TI-84 or most graphing calculators. You can also do this on Desmos, just change in settings. Desmos, you'll see you can change it right to polar, and then you can type in R equals. I'm not sure if that lets you do R squared yet either, but the calculator also can, so we'll be a little more clever on how to do that. So I'm just going to start by graphing one of these basic ones over here. We'll choose this for cosine. And I'm actually going to reset my calculator. And I would do the same thing. So we're kind of in the same spot. So I'm going to do a 7, reset, all, and reset. All right, so we're back at the beginning. First thing first, we're going to go to mode. And let's see, I can make this a little bigger for you guys to see that. Clear off. So I'm going to go to mode. And then down, you can see I'm going to highlight function. We have now graph parametric, and here we go to polar. So I'm going to hit enter. And now when we go into our entry for the graphs, it's an R equals instead of a Y equals. I can also see that my calculator is in radian mode, which I prefer for this. So you guys can graph whatever you want. But remember, for radians, one full circle is 0 to 2 pi versus degrees 0 to 360. So that will come into play with the window. Okay, so I'm going to throw in for cosine, and then when I hit the X button, it gives me a theta. And before I graph, I'm going to go check my window settings. So this is where if your graph looks weird, check your window. So right now it's graphing from 0 to 6.28, which is 0 to 2 pi, which is usually okay. But remember, these graphs graph in a circular fashion. So it's not like our X and Y domain and range from before. So if you don't see a full graph, you might want to change these, sometimes making this negative or going more. I'm just going to change this to, I'm going to go to 4 pi. And you'll see it might just start graphing over each other, but that's okay. We want this step to be pretty small. I'm thinking it's okay now, but if your graph is not smooth, that means you need to make your step smaller. If your graph is taking too long to graph, it's only graphing tiny pixels at a time, you need to make your step bigger. And then our X min and max is going to show us our window. I'm going to leave negative 10 to 10. And the Y min and max, same thing. That's just to set really how big the window is around your graph. But that theta is the important part. You can change the scales, everything going through there. I don't think there's anything else we need to do. I don't think there's any settings down the bottom here. Nope. So let's hit graph and see what happens. Now, it looks kind of ellipse-like, oval-like, but it shouldn't, right? So the first thing I'm going to do is I'm going to go to window. And I'm going to go to zoom. I'm going to do zoom square. Our screen's a rectangle, so it's like stretching out our x-axis to match the y. So I'm going to hit 5, and there we go. There's our circle. And from here, we can zoom in and out. So you guys on your worksheet can graph that. It's a circle, and if we count on the x-axis, or the polar axis, it's going out 4 units. And you can always change your scale right on these graphs if you want to. So go ahead and graph these on your calculator. Maybe you don't need your calculator. See what they look like. So I'm going to do number 2 down here on the calculator, just so you guys can see what I mean by some of this stuff. So I've got 1 plus 2 sine theta. I think my window should be fine. I'm going to hit graph, and I'm actually going to zoom in. So let's do a zoom in. Just hit enter. Not bad. We're a little off, and I can move up too also if you want to. Zoom. Best way to do this. Let's try square and see where that puts us. That's fine. Hopefully we could see it. I'm just going to change my window. Try to make it the best square I can. X min negative 4 to 4. So I'm going to go down and change my X min. Let's go negative 5. So negative 5 to 5, and then we can change the Y. Negative 3 to 3. That might just be enough. I'm going to add a 0.5 on there. Might have to play around with your windows so you could see the whole thing, but you can always zoom in and out. Not bad, not bad. Okay, so we draw that on there, paying attention to, I call this guy up here the max R height, right? Our max radius it gets to. So it looks like that's 1, 2, 3 units. And I'm going to scale this up by like 2 lines. Let's write down here. This will be a 1, this will be a 2, this will be a 3. So up here, that's my max R value. The loop height is what I call this point. So that kind of second value in there on the polar axis for this one, and that's at 1. So for this one, we would write max height or max R value is 3, loop height is 1. Maybe we could start seeing a pattern where this comes from. And this guy does have symmetry with respect to the line theta equals pi over 2. Filling that in for us. And you guys can graph this. I would pay attention to these intercepts because we should also start seeing patterns with those. So a little loop-de-loop, I think it kind of looks like a lily pad. Limaçon, I think that means snail in some language. I want to say French, or someone told me that. Maybe it looks like a snail, like on the front. I think if you do like a little face on this guy, maybe a snail. Who knows? I think I heard that somewhere. But you guys hopefully got the idea of graphing with the graphing calculator, and that should get you through most of this exploration.